Hello, can you hear me? Hello, hello, everyone. Can you hear me clearly?
Yes, we can. How you doing?
Yeah, how are you? Okay, so give me 1 minute. Let me put this thing down. Yeah, I got this one. Smith. Okay, so okay, one more person coming in. Look, wow, very good. New person. Oh, got it. All right. Then I will start with we started the concept of probability last week, and we finish it today. So that next week we jump into probability distributions. Before we start, I want to take you to the classroom um, for a brief explanations. If you look at the announcement for week 11, see, we are still on chapter 4 and 5. We're still going to be in chapter 4 and 5 because chapter 5 is probability distribution. So it's still going to be there next week. But we will finish the introduction to probability today. Um, then the classwork 8. The same homework that was due last week. Actually, not due last week. It was due. It had been due this week. So that's homework 5 due on Sunday. And having said that, let's begin. So last week, we covered a lot of ground, some of the rules of probability. Today, we look at conditional probability and a special type of conditional probability that we call Bayes' theorem. So what is conditional probability? We use this to measure um, the probability of an event occurring, given that another event have already occurred. For example, somebody getting an A in a class, given that that person have been studying, and that person have passed the tests and homework and classwork given for that class. So that is the first event. Second event means getting A. Um, so one event have occurred. The person passed the test and homework and assignments, then getting A. Another one is getting a scholarship, having a good grades and getting a scholarship. The condition is that you have good grades, then get a scholarship. So we call it conditional probability. I'll give you another example. Getting a job, given that you already have a degree about that job. For example, somebody who has a degree in accounting, getting a job as an accountant in a government agency or private organization. See, the condition, you already have a degree in accounting and experience, of course, they like experience too. That's the condition, then you get a job. So we recognize that in statistics and we call it conditional probability. This is how we write the formula. Probability of A, this forward slash here means given that. That's what it means. Given that. So that this means that the probability of A, given that B, the probability of event A occurring, given that event B has already occurred, equals the probability of A and B divided by the probability of A. Sometimes you can use N here instead of P. Number of points in A and B divided by the number of points in B. Let's see how it works. I'm going to use this example here. Give me 1 minute. Let me get something. Get something from here. Stay there. Uh, Give me 1 minute. Okay. See. Yep. All right, okay. Let's try this example. It says the test results for marijuana use is presented here. You can see, does the subject use marijuana? You can see yes for the subject, no for the subject. Then the result, positive result. Positive result means that the marijuana is present in the blood, and negative result that is absent. So the question was, choose one subject at random, find the following probabilities. A, the subject tested positive, given that he or she actually uses marijuana. B, the subject actually uses marijuana, given that he or she tested positive. C, the subject tested negative, given that he or she uses marijuana. So the first thing to do, of course, is to find the totals for the columns and rows. So you can say 119 plus 24 plus 143. 3 plus 154 gives us 157. And this 143 plus 157 gives us 300. And 122 plus 178 gives us 300. So this marginal totals must add to the same grand total. Now we can now identify the variables. We use M to represent that subject uses marijuana, and P that he uses positive, that is tested positive. So the question is, the subject tested positive given that he or she actually uses marijuana. Okay? Okay, you can see the formula here. A and B divided by B. You can use any letter to represent A and B. For example, here we're using M to represent marijuana use and P to represent positive. So that it says, find the probability that the subject tested positive. Okay? We have tested probability that he tested positive, given that he or she uses marijuana. Okay? So let me I'm gonna copy this rule here so you can be looking at it while we solve it. Okay, I'm gonna copy it right here and paste it here so we can be looking at it. Okay. Now, so again, we use M to represent B, and you use P to represent A. So positive, given that it uses marijuana, becomes positive and marijuana use. When you come here, you can see this is the positive, which is yes. Sorry, yes, positive result. Given that, because it says the subject tested positive, given that he or she actually uses. So you're gonna be positive P, given that M, which means that he uses marijuana. So you can look at it here. Positive results, yes, that he uses. You can see that positive and yes intersected here. This section, this box, this number shows positive result, given that positive result, somebody that tested positive results that and also uses marijuana. It represents A and B, or in this case, M and P. Okay? So it's gonna be 119 out of 300. So not out of 300, 119. 119, I can put it this way. Probability of, I can use number of points in P and M divided by the condition that's given that he uses marijuana. Number of points, okay, is this in M. So this will give us P and M is, like I said, it's right here. Represent positive result and uses marijuana, which is 119. 119 divided by given that he uses marijuana and a number of points in M. And for marijuana use, you can see the yes here. Total for that is 122. 122 right there. 122. And that gives us the probability. I'm going to write this down so we can get it from the calculator. That with the space here. 119 over 122. So we go to the calculator and get this rate. I'm going to put my calculator. This much. Yeah. 119 divided by 122 was 0.975. 0.975. Let me write it down. 0.975. Zero point 975. Or you can say that there's 97.5% chance that the subject who tested positive also uses marijuana. Part B says the subject actually uses marijuana given that he tested positive. So in that case, we have part B, excuse me, part B, the subject uses marijuana M given that he tested positive. Going to be number of points in marijuana and positive. Positive. Now this time around the condition changed. The condition is that he uses marijuana, given that this place is given that the condition is really given that he uses marijuana. In this case, it's given that he tested positive. So this is going to be P. So even though the numerator will be the same, the condition changed. Again, marijuana uses M and P. You can see right here. Yes, uses marijuana, tested positive. Again, they intersect here. 119. 119 divided by that. The condition now is that given that they tested positive, I can see the positive result here. Positive result total is 143. 143. So I'm gonna put it that way. 119 to 143. Okay. So you have 193 by 143. So that so 119. So I'm gonna change this to 143. 0.832. So that means that the probability that somebody who tested positive uses marijuana will be 0.832. Or there's a 3.2% chance that the person who tested positive actually uses marijuana. Now, part C says the subject tested negative, given that she uses marijuana. I'm going to use N for negative, N for negative results. So now this question is asking us to find the probability that the subject tested negative, given that he uses marijuana, which is M. So we because that's what it says. The subject tested negative, given that he or she uses. So we have number of points in negative and marijuana use. Then the condition now is that given that he uses, that means number of points in that they use. Okay, this will give us, excuse me, this will give us go to the table, number of N and M. You can see right here. Negative results. Yes, they intersect at 3. 3. So 3 over, given that it uses, which is m, as yes, it's 122. 122. Okay. Let's say I'll write it here. 3 over 122. Let's go and put this on the calculator. 3 over 122. Yeah. Martins. Yep. Let's go to the calculator. We got 3 divided by 122 was 0.025, approximately 0.025. So go to this place. 0.025. So there's 2.5% chance that the person who uses marijuana tested negative. It might even be a false negative. Yeah, because we have that situation sometimes where we have false positive and false negative. Now, any question in what I've solved so far? Any question? So no question. Excellent, excellent. Now, let's try a simple one. It says here, 2 cards are selected in a sequence from a standard deck of 52 cards. Find this probability. Find the probability that the second card is a queen, given that the first card is a king. Assume that the king was not replaced. Now, I use K for king and Q for queen. Now, this is a kind of conditional probability. It says, we know as in a deck of cards, we have 4 kings and 4 queens. You guys know that already. Look at this right here. So you have queen 1, 2, 3, 4, and king 1, 2, 3, 4. Now it says in this deck, it says find the probability that the second card is a queen, given that the first card is a king. Assume that the king was not rejected. Okay, so we're looking for the probability of excuse me, sorry. Okay, I'm gonna make it probably make it 18 and unbold it. The probability that the second card is a queen, given that the other one was the queen, that the first card is a queen. Or king, sorry. Given that first card is a queen. Okay. Now what you say, but remember the rule here that assume that the king was not replaced. Okay. So when you select the first card, before you make the selection, there are 4 queens and a total of 52 cards. When you made the selection and you did not replace it, we now have 3 queens left out of 51 cards. But king was not affected. And that is what the one sorry. One king was selected. Okay. Okay, king was selected. So there are now 3 kings left, but they still have 4 queens. The queens are not were not affected, but the total of number of cards left is now 51. So that the probability that the second card is a queen, given that the first card is a king, is 4 queens out of the now 51 cards. And that gives you your answer. 4 over 51, 4 divided by 51. You can get this from the calculator. 4 divided by 51. 0.078 approximately. 0. 0.78 approximately. We got 0.078 or 7.8% chance. Any question on this? Any question? No. Okay, good. Excellent. Excellent. So now, to round up the conditional probability before we can jump into Bayes' theorem, let's look at what is a special type of probability that is called at least one. The probabilities of at least one. When they say that to find the probability of at least one, it will remind us of the complement rule. The probability of E equals 1 minus probability of E complement. So when they ask you that question, find the probability of at least one, it's better to find the opposite probability and subtract that answer from one to get the probability of at least one. I agree as an example will make this more clear. Look at this question. It says, again, right, let me make this to be 18. Say, a game is played by drawing 4 cards from an ordinary deck and replacing each card after it is drawn. Find the probability of winning if at least one ace is drawn. Okay? So let's solve this. How many aces? We have 4 aces. 1, 2, 3, 4. Out of 52 cards. So, the card is, it was replaced. So, we still have it there. So what this rule is saying, you win when you draw at least one ace. So, to find this, after this question, find the probability that there's no ace found. You did not select any ace. There are 4 aces now. So, if you don't select any ace, any of these aces, so that means you have 48, only 48 cards are not aces here. So the probability that there's no ace will be that would be 48 out of 52 cards, because it said that it was replaced after each selection. So let's say that an A is at least no ace, at least one ace is drawn. B is the opposite, no ace. So let's find the B complement probability. Have it here. Probability of no ace is no ace. Okay, this is a complement, so I'm gonna make it up. B 1 minus probability that ace is selected. Okay. Now, but let's find the probability of ace first of all. Remember, so my mistake. Probability of ace, let's find the probability. We are looking for the probability of ace, not yeah. The probability of finding ace. There's no ace. Like I said, there are 52 cards. 4 of them are aces. If you remove the 4 cards, 52 minus 4, you have 48 cards that have no ace. And this is 48 out of 52 cards are not aces. But they say that 4 cards was selected. Remember, they don't select 4 out immediately. They select it 1, 2, 3, 4. They're going to be still 4 times. So that means the probability of no ace will be 48 over 52 times 48 over 52 times 48 over 52. So raised to the power 4. So that will give us no ace is drawn. So I'm going to make this. No ace is drawn. So 4 over 52 raised to the power 4 will give us 4 over 52. 4 divided by 48 over 52. Okay. Raised to the power 4. That means 4 to multiply 4 times to the power 4. Give us 0. 0.0 0.726. So that means let's give out the probability that no ace is drawn. 0.726. So now, but what we are looking for is to find the probability of winning if at least one ace is drawn, at least one. That's why we're gonna apply this formula for the complement formula. So that the probability of at least one, which is probability of PA, at least one will be 1 minus probability of no ace. A complement. Okay. A complement, which will be equals 1 minus, we have a complement here already, no ace here as 0.726. 0.726. And that will give us the answer we're looking for. Equals, so 1 minus that. So we got 1 minus 0.726. 1 minus 0.726. Oh, oh. Yep, 726. 726 is 0.274. It is 0.274. Or there is 27.4% chance that of winning if at least one ace is drawn. Any question, guys, on this? Any question if you have, ask. Any query? Be good. No question. Now let's try another one of this type. Probably that might clarify this better. Or maybe two more of this type. Yeah. Let's try two more. One that involve gambling again, and one that involve real life situation like insurance. Okay, or retail business. So let's try the one that gambling again. Let's look at this. A coin is tossed 5 times. Find the probability of getting at least one tail. The coin have two sides, so each side have 50-50 chance of appearing when it is tossed. So you say find the probability of getting at least one tail. Okay. So let's use T for getting a tail and T complement for no tail. Okay. Now we can now try this. So that the probability of getting at least one tail will be probability of T, at least one tail, will be equals 1 minus probability of T complement. Okay. As the formula, that's the same formula we use. Right. Remember, we use that formula whenever they say at least one. When they say at least one, that's when you use the complement formula. You can see that we use it here. 1 minus probability of A equals 1 minus probability of A complement. Okay, each time you say at least one, we use it. So, but let's find the complement probability first. Probability of getting no tail. The principle says find the opposite probability, subtract it from 1 to get the probability of at least 1. Yeah? Complement. So let's find what it is. Now, you know that when it comes to coin, like I say, it's 50-50. It's 0.5, 0.5. 1/2. That's 1 out of 2 chances in each for both tail and head. So now, for the coin, it said it was tossed 5 times. That means 1 out of 2 chances times 1 out of 2 chances time, because it was tossed 5 times all the way to the 50th time. So the best way to make it 1 out of 2 chances raised to the power 5. Okay? So that will give us the opposite probability of no tail. 1/2 raised to the power 5. So let's go and get this from the calculator. We got 1 divided by 2 raised to the power 5. 0.031 approximately. 0.031 approximately. That is of getting no tail. So go back and put it here as 0.031, so that the probability of getting at least one tail, again, we have it here. I'm just going to copy it and put it right here, equals 1 minus probability of getting no tail, which is 1 minus 0.031. Yep, 31. You have 1 minus that. So you got 1 minus 0.031 was 0.969. 0.969. 0.969. Or that's 96.9% chance of getting no tail. Okay? Of getting 96.9% chance of getting at least one tail when the coin is tossed 5 times. Any question on to this? Yeah. There's no question. Good. Excellent. Now let's try this one, the application when we apply it to a retail, a real life situation other than gambling, like in the retail. It says here, the Neckwear Association of America reported that 3% of ties sold in the United States are bow ties. If 5 customers who purchased a tie are randomly selected, find the probability that at least one of them purchased a bow tie. See, again, they use that keyword, at least one. Okay, that tells you you're gonna use complement rule. So let's say B is for bow ties, right? Let's say that B complement is no bow tie is purchased, and B means at least one bow tie. So we'll find the B complement first, which means no bow tie was purchased. So that the probability, okay, P of no bow tie, that's B complement, will be there's no bow tie was purchased, will be now the question said that the Neckwear Association of America reported that 3% of ties sold in the US are bow ties. That means 3% of the ties, 3% of the bow of the ties sold or purchased are bow ties. So then the rest are not bow ties. So the opposite will be 100 minus 3% is 97%, right? Because 53% is sold. So 100 minus 3%. 100% minus 3%. Those are not both ties. Will be 97%, which is equals to 0.97. So these are the ones that are not both ties. Equal sign here. So find the probability of no bow ties. Then to find out, before you can now find at least one bow tie purchased. So that means 0.97, 0.97. He said 5 customers were selected to find the that purchase tie. Find the probability that at least one of them purchased both tie. So find the probability that no both ties was purchased by any of them, which is 0.97. So since there are 5 of them, raised to the power of 5. Okay. I want raised to the power of 5. So I'm gonna write this down so I can get it from the calculator. I got 0.97 raised to the power 5. 0.97 0.97 raised to the power 5 give us 0.859, 0.859 approximately. Okay, we go about the answer. 0.859 0.859. So this is for this, the probability that they did not buy any bow tie. But we're looking for the probability that at least one of the tie they purchase is a bow tie. So for that, we're gonna use the formula probability of at least one. I mean, P of B, where B represent the bow tie, at least represent at least one bow tie was purchased, will be equal to 1 minus probability that no bow tie was purchased, which is we got as 0.87859, 0.859. Oh, a mistake. Minus 0.859. And that will give us the answer we're looking for. I'm gonna do that here. 1 minus 0.859. So got 1 minus 0.859, 0.141. So 0 point, I didn't write it down. I didn't forget it. 0.141. Okay. Which is 0.141. Or you can say that there's 14.1% chance that at least one of them purchased a bow tie. Any question to this? Any question? Hello, scholars, can you hear me? Hello? Everyone, are you there?
Yeah, we're here.
You here? Okay. So you guys give me 1 minute. Let me use the restroom. I'll be right back so that we can continue and finish up. Just
All right.
1 minute. We go and take this restroom and come so I can finish this up today. So at next week we begin with the the probability distributions. Now like I said, let me give me 1 minute to use the restroom and I'll be right back. Ah. Well, so I'm back now. For those of you, there's some of you who logged in and then disappeared. Remember, you get your point for attendance, but you cannot get point for participation if you just log in and disappear and start doing something else. Participation can include asking questions, responding to my questions. The question have to be questions that have to do with what I'm teaching. So if you logged in today and then disappeared, start doing something else and don't participate, remember, you can't get participation. You will get point for your attendance, sure. But for participation tonight, you can't get point if you don't participate, okay? All right, let's continue. This brings us to Bayes' theorem. Bayes' theorem is a special type of conditional probability where our main interest is to find the chance or the probability that some event or an event will occur, given that, given what you already know. So now the formula it can look like a monster, but it's boiled down to this. The probability of event AI given B equals probability of B given AI times probability of AI over probability of B given AI times probability of AI plus probability of B given A2, so actually A1 times the probability of A1 plus the probability of B given A2 times the probability of A2, all the way to the last one, where A1 and A2 are mutually exclusive events. A1, A2, A3, A4, depend on number of events involved, are the mutually exclusive events. Okay? I think that the conditional probabilities are given to be B given A and B, A1 and B given A2. And then you can just stop at second one, which means probability of A1 given B becomes probability of B given A1 times the probability of A1 divided by, you repeat that same one that you're looking for, plus the other event, which is the A2 event. That is probability of B given A2 times probability of A2. Don't worry, when we solve a few examples now, it will clear the confusion. Let's try this one here. It says, a book club classifies members. Okay, I'm going to make it 18. A book club classifies members as heavy, medium, and light purchasers. Heavy purchasers, medium, and light purchasers. Okay. Separate mailings are prepared for each of these groups. Overall, 20% of the members are heavy purchasers, 30% are medium purchasers, and 50% are light purchasers. A member is not classified into a group until 18 months after joining the club. But a test is made of the feasibility of using the first 3 months purchases to classify members. The following percentages were obtained from existing records of individuals classified as heavy, medium, and light purchasers. Remember, these percentages are actually represent probabilities. You can see heavy, how much they purchased in the first 3 months. No purchases, those that did purchase, 5% of them are heavy, 15% are medium purchasers, and then 60% are light purchasers. Those that bought only one book during that first 3 months. Among them, 10% are heavy, 30% are medium, and 20% are light. Those that bought 3 books, among them, the 30% are heavy, 40% are medium, and then 15% are light, and so on. He said, if a member, make it 18. If a member is, if a member purchased no book in the first 3 months, what is the probability that the member is a light purchaser? So remember, you are given the prior probability that overall 20% of them members are heavy purchasers, 30 are medium, and 50 light. Then they give you additional probabilities of what happened during that 3 months. So now let's solve this. Say if a member purchases no books the first 3 months, what is the probability that that member is a light purchaser? Let's identify the variables first of all. Solution, excuse me. Okay. I'm going to move this to next page so that we have enough room. We have enough, okay, to do solutions. Let's say that we use H for heavy purchasers. Purchasers, yeah? And M for medium purchasers. Okay? And L for, excuse me, it could be capital L. L for light purchasers. So the question is asking us if a member purchases no book in the first 3 months, what is the probability that the member is a light purchaser? So that means we're looking for the probability of light purchaser. Now why this keep changing to font size of 16 of light purchaser. Okay, let me identify all the variables. It says if a member purchases no books in the first 3 months, what is the probability that the member is a light purchaser? So let's use 0. I mean, member purchased no book. Okay. Now, to answer this question, we need to get our numbers straight. We are told that overall 20% of members are heavy purchasers. So we have H equals 20%, which is 0.20. Then for medium, we say that originally that it is overall is 30% are medium purchasers. So 0.3 at 30%, which is 0.30. Then light purchasers, 50% are light. L equals 50%. Okay. Which is 0.50. Okay. Now, next will be to find the other variables we need. For say, if a member purchases no books in the first 2 months, what is the probability that member is a light purchaser? Look at 0 books. Those that didn't buy any book. 5% of them are heavy, 15% are medium, and light is 60%. So that the probability of zero book, given that member is heavy, is 5%. Heavy equals 5%, which is 0.05. Probably that's zero book. Given that it's a medium purchaser, maybe bought no book, given that is a medium purchaser, is 15%, which is 0.15%, which is 0.15. Then bought no book, given that R is light purchaser. Maybe if you go over there, you can see right there. Bought no book, and given that it's light, which is 60%, which is 0.60, 60%, which is 0.60. When you have all these things together, you're ready to solve this using the Bayes formula. Remember the Bayes formula from here. Okay. So that means it says if a member purchased no books in the first 3 months, what is the probability that the member is a light purchaser? So we're looking for here, what we're looking for here is the probability that a person, I gotta make this 18. A member is a light purchaser, given that he or she bought no book. That's what we're going to do. So we're gonna use the right variables to represent this variable we use in the general formula here. So and then after we put that together, we can now put all these numbers inside the formula and get our answer. Unfortunately, this session will not allow us to put the formula here, so I'm gonna just write it down, and then we can write all the variables down, and then I will go to the other workbook where we can put the formula together, then bring it back here, okay? And then solve it. What is my piece of paper? Okay, let me draw this one. Let me write all this down so we can go and get it from those and bring it back here. I got we have H equals 0.20 for heavy purchaser. Then for medium, 0.3, 0.30. For light, 0.50. Then no book given high purchaser, heavy purchaser. Zero book given heavy purchaser is 0.05. No book purchase given medium, P0 given M is 0.15. Then probability of 0 given light purchasers, maybe 0.60. And then we are looking for this, the probability of light purchaser given that he didn't buy any book. Because that's what it says here. If the member purchased no book in the first 3 months, what is the probability that the member is a light purchaser? So looking for P of light purchaser, given that he purchased no book. So now let me take you to that workbook so we can generate the formula. This is the underworld document we use as the workbook. So we're looking for the probability. I'm gonna make this big. Okay, the probability that oh, excuse me, that the member I'm gonna put it right here, is a light purchaser, which is L, given that bought no book, zero book, equal, put the formula in, got probability of, okay, 0 given light purchaser, okay. Oh, excuse me, sorry, my mistake. Probability of 0 given light purchaser, 0 given light purchaser, okay, times, I'm gonna use it, this times right here, times probability of light purchaser divided by probability of um probability of 0 given light, excuse me, given light purchaser times times Q of light purchaser plus. So now you repeat this for of all the variables, for you repeat it for heavy and medium. Okay. So probability of 0 given 0 given heavy purchaser times the probability of heavy purchaser plus the probability of 0 um 0 given medium purchaser times the probability of medium purchase. Okay. Oh, excuse me. So that's the formula right here. So we can let me take you there. We can plug in these numbers. Okay, we have maybe 16, so to accommodate it. Copy it. So Bayes formula. So that is right. Put it right here. That's right here. So all you need now to plug in these numbers. We have them here already. L probability of 0 given light purchase, I can see right here 0.6. So now we can just plug this in, which means that, oh, excuse me. Yep, can see it. That the probability of light, that is the light purchase, given that he bought no book, becomes, he'll have P given 0 given light, you can see have here as 0.60 and call it, put it 0.60 times the probability of light, given that it is 0.5, since L 0.5. Okay. Divided by, now, under the denominator, we have all this. So we're going to make it parentheses, have, I'm going to put it double parentheses, double brackets, then have this, probability of 0 given light, have it at 0.6 times probability of light, which is this one, 0.5, plus probability of 0 given heavy, we have it here as 0.05. Okay. Times probability of heavy, have it here as H.2 to 0. Plus, no, this, let me try to see if this can enter here. The probability of 0 given medium purchaser, 0 given medium is 0.15 times the probability of medium purchaser, which is 0.30. Then close the parentheses completely. So I'm gonna okay. So you can see that close the parentheses right here. So now we'll put this in the calculator and you get the answer. Let me write this on paper so you can put it in the calculator. We got I can put it yeah, put it right way. We got 0.60 times 0.50 over we have 0.6 0.60 times 0.50 plus 0.05 times 0.20 plus 0.15 times 0.30. So we can go and put this in the calculator to get our answer. Okay? Take it to the calculator. Have you got 0.6. Okay. 0.60 times 0.50 over parenthesis 0.60 times 0.50 parenthesis plus 0.50 0.50 times 0.20 plus 0.15 times 0.30. Are we missing anything? Got 0.674. 0.674. Let me make sure we didn't miss anything in the numbers. Okay. I think we missed something up. Let me see what we missed. Let's go to this place. Okay, we have 0 for this. For this one, 0 given that is heavy purchaser. 0 heavy, okay. 0 given that is light purchaser. Okay, okay. 0 given that's a medium purchaser. 15, okay. Now for overall 20 heavy, 30 medium, 50 light. 20 heavy, 30, okay, and then 50 light. So if we plug all this in here, 0 given light, which is 0 given light, okay, times probability of light. Oh, this is right here. Probability of light is 0.5, okay. So 0 given, let me see what I did wrong. Okay. 60, okay, then 0.05 times 60. Okay, so 0 given heavy. 0 given heavy is 0.05 times probability of heavy. Okay, heavy is 20. Okay, plus 0 given medium, which is 0.15 times probability of medium, which is 0.3. So let me see what went wrong in the calculator. Everything seems to be nice here. Okay. Okay. 50. Okay, see, okay, 0.50 times 0.5. Okay. plus 50 times 0.5, 50, okay, 0.05 times 0.3. Okay, I see the mistake. 0 given heavy is right here. 0 given heavy, 0.05 times the probability of heavy, the heavy purchaser. Okay. Then 0 given 0.05 times that, okay, 0.15 times 0.30, and everything looks good. What do I put the calculator? 0.60 times 0.5, 0.15 times 0.3, okay. Then 0.05 times 0.2. Yeah. So it's from the calculator. Let me see what I did on calculator that is not good. 0.6 times this. 0.5 times 0.2. Oh, I see it right here. 0.05. I wrote 0.5, so 0.05. 0.05. Okay, got it. Okay. Times 0.05. Okay. I wrote 0.5 instead of 0.05. That's what happened. Okay. So answer would be 0.845. Let me write this down. 0.845. 845. 0.845. 0.845. So I have the probability that the say if a member purchased notebook in the first 3 months, what is the probability that the member is a light purchaser? So as a light purchaser, given that he bought or she bought notebook, becomes 0.845. Or you can say that there is 84.5% chance that a member who purchased notebook during that month, that's 3 months, is a light purchaser. So this is basically how it goes. Any question to this? Any question, guys? Hello, can you hear me? Like I explained, participation also carry points. So if you log in and just disappear and do not participate, you get a point for attendance, but not for participation. So let me ask again. Any question from the floor for me? Hello, guys. Are you there? Mr. Brandon, you there? Mr. Miss Kania Brown, are you there? Mr. Bullock, are you there? Mr. Nathan? Sam Rex, are you there? Tania Smith? Sammy Omotosho, are you there? So all of you will not get participation credit then. Any question for me before I leave?
Nope.
So what's your name, sir?
Nathan.
Nathan. So only you responded. So that means only you getting credit for participation. Nathan, who again?
Nathan Corte.
Okay. All right. So those of you who did not respond, remember you get credit for coming, but not for participation, okay? You can't just log in and leave. All right. I'll see you guys next class. Have a nice evening.
All right, thank you.
You're welcome.